Good evening, folks. We have a function that's specified abstractly. Now let's just take a look at what we could do to come up with a concrete instance of such a function. Okay, and then when we come up with that, we're supposed to integrate it, okay, over a specified interval. So notice that square root of 3 times the square root of 3 4 times. That's certainly equal to 9, that's equal to 3 times 3, right? If you do things pairwise, that's equal to 3 times 3, which is 9. Okay, so what does this suggest? It suggests that we look at f of x equals to x to the fourth, because that's exactly what just happened with the square root. So we'll call f of x equal to x to the fourth. And it's very easy to verify that this function would meet this condition, right? And again, you can check, but if you raise this to the fourth power, you do get 9, and you get x to the fourth. And right here, you have 9x to the fourth. So f of x, if we're limiting ourselves to monomials, f of x equals x to the fourth would be a concrete example of a function, maybe the only one, that actually satisfies this initial condition for all real x. All right. So again, we would get m equals 4 right here, and so it becomes quite easy to integrate this expression using the function x to the fourth. This would be equal this is real basic fundamental theorem of calculus. An antiderivative, let me write this down, of x to the fourth dx is certainly x to the fifth over 5, and that's just differentiation in reverse. If you differentiated x to the fifth over 5, you get x to the fourth, where differentiation is the inverse of integration. Now, so what does that mean? That means that we have 1/5 times what do we have here? 2 raised to the fifth power minus a -1 raised to the fifth power. Okay, so the minus sign will be canceled. -1 raised to the fifth power is -1, and so this would end up yielding 33 over 5 as our solution. So that's the answer to this problem, folks. Now, I would like to say that in general, if you have something in this form, or maybe a better way just to write this would be, it would be x, your f, and I'll write this a little more, I don't know, symbolically, I guess. F of x would be equal to x raised to log base root 3. Now, BlackPenRedPen did this, but the numbers didn't work out nicely. Here it worked out nicely, but this would be log base root 3, okay, of 9. Okay, and as logarithms go, this is the very same thing as x to the fourth, right? Because you have to raise root 3 to the fourth power to get 9, right? So what a logarithm is, it's an exponent. All right, folks, so that's the more abstract way of, or the way to do it in general for just numbers other than root 3 and root 9. I picked those numbers intentionally to work out to a nice monomial. The Harvard, the HMMT tournament, a long time ago, I think the numbers were something like 2 here and then 3 right here, right? And so you would have actually gotten a concrete monomial of x raised to the log base 2 of 3, which is an irrational number. And when I integrated it, I didn't get the same thing they got. So I'm not even sure if they did that right. They just tried to do it abstractly without using properties of the integral and stuff, the splitting principle and all that. And they got an answer that I didn't get, but this would be an antiderivative. You know, this would be not, excuse me, this wouldn't be an antiderivative, but this would be the form of a function that you could integrate. They never did it that way. They just used properties of integrals. But in any event, I'd like to know if any of you watched that and agree with me on that. I'm not so sure the answer they gave on that was I think they got 5 or something. But anyway, this is slightly different. I just did a direct integration once we came up with an integrand. But anyway, I'd like to know what you guys, if anybody saw that and agrees with me, if it's just something I'm overlooking. But in any event, this is equal to 33 over 5. Check and see, is that we got it? Yeah, 33 over 5. Thank you all for viewing.